Welcome to section 3.2. This does say percents, however, part 2 is working with the equations with fractions, also known as rational equations, rational being fractions. So our first example you'll only find on part A, which has several fractions being added together with a common denominator, 5, 5, 5, and 5. We have two different ways to come about this one, both of them equally fine. However, I know a lot of you are going to kind of have a rise in blood pressure when you're looking at fractions because it kind of has this mental block that fractions are hard. So one of the things I like to do is get rid of the fractions. If you don't like them, bring your blood pressure down by getting rid of them. It's so nice, it's so fast, and it kind of calms your nerves to see that there's no more fractions. So we have two ways of doing that. The first way is, because these are all common denominators, I can go ahead and combine these fractions. So I'm going to keep things nice and readable. So I'm going to insert my equation. I'm going to copy this, paste it in here. Oh, I don't need it to. Okay, so in combining these fractions, because they're the common denominator, these are, that's a 13. I'm going to come over here, and up on the top, all I do is add my numerators. So it's x plus 13 over 5. Same thing over here, except that it'll just be a minus 3x on the top. Oops. Minus 3x. And I'm just moving my arrow buttons to maneuver through this equation. Okay, so now that I have that, the next thing I do, some of you are thinking, well, we learned a long time ago that you can do something called cross multiply, which is times the top and bottom here and the top and bottom here. You could do that, that's fine. And what you'll end up with is a 5 out in front of this and a 5 out in front of this. To get rid of those 5, you'll divide by 5, which cancels them out on both sides. Another way of thinking about it, which I'd rather prefer, because we're going to be doing it a bunch of times, is multiplying everything by the same number on every single term on both sides. The reason I do that is that's how I get rid of fractions. So in this one, I look for the least common denominator. The least common denominator between these two is thankfully the exact same number. So I just multiply both sides by, come back in here, multiply it by 5. And we learned earlier that if I have something on the top and the bottom, they cancel out. I don't think my strike through feature, oh, yep, it works. So it cancels out here. But I can't just go around multiplying something on one side, so I need to multiply it on the other side as well. So I'm going to multiply 5 to this side, and that cancels out. There it is. Cancel out. And there is the miracle. No more fractions. Nothing is left. So I have x plus 13 equals 21 minus 3x. And those of you with anxiety about fractions, hopefully that just kind of resolved because there's no more fractions. Okay, so that's the first way of doing it. The second way kind of works us into what we do later. So the second way, instead of combining my fractions, because not all of them are going to be nice and have the same common denominator, what I do is I still look for the least common multiple. And if you're struggling with the least common multiple, you can either do a Khan Academy search, or I provided one on the notes from instructor. I'm also thinking about making a quick tutorial about finding the least common multiple, or the least common denominator in our case, because the least common multiple in the denominator is called the LCD. In our case, because there's only one denominator, there's only one. It's just 5. So what I do here is I take this 5, and instead of just multiplying it by the top and bottom like this, these ones are separated by an addition and a subtraction sign. So what I do is I multiply it to every single term, and those are separated by addition and subtraction signs. You're thinking, well, wait a minute, down here there's also an addition and a subtraction. But you'll notice these are combined on the top of one fraction, so there's really only one term on the left side of this and only one term on the right side. In this one, to do the part that's going to move us into the next section, I'm going to come over here just to kind of parallel them. I need to multiply it to every single term. So I need to do 5 times here. I need to do 5 times here. I need to do 5 times here. And let's get that back up here. Oops. Bring that over and do 5 times here. And you'll notice, because I have all of these fractions, the 5 will cancel out with every single one of these denominators. One on top and one on the bottom. Cancel. Cancel. I know this is taking a little bit of time. If you were doing this by hand, it'll go faster. In Math 108, however, you do have to show your work in Word, so you'll kind of have a step up on those who haven't seen this. There you go. So now all of the 5s are gone because it canceled out. I had one on top and one on bottom. And the reason I can do that is if I keep it balanced on both sides of the equation, then it's balanced. And what am I left with? Oops, tab over. What's left over here? Well, the x isn't canceled. Oops. It's carrying that over. Let's get rid of that. Okay, there we go. So the x isn't canceled. Addition, the 13's not canceled. The 21 isn't canceled with anything. There's a subtraction sign there. And a 3x. Looking similar? It's the exact same thing. Now we can continue. So you have 2 ways to do this. If you have where they are the same, you can go ahead and combine and then cancel. However, this one is what we're going to be doing for the next part. And you'll notice that because we ended up with the same thing, it doesn't matter which way we go if they have the same common denominator. Now it's just a matter of combining. So I pick a side for the x's. It doesn't matter. In fact, let's do it both ways so that you get a C. On this one, I'm going to move the x's to the left side. On this one, I'll move the x's to the right side so that you can see that it doesn't matter whichever way I do it. So over here, if I want the x's to come over to the left side, I need to add the 3x over to here. So I have x plus 3x. Now we could go ahead and skip this step. We probably shouldn't. Let's go ahead and just put the 13 here. Oops. Equals the 21. Now on this next step, let's go ahead and subtract the 13 over. So we could have done that on the same step, but let's not. I don't want to lose anyone. So now I need to subtract the 13 here and combine what I have. Okay, let's combine the left side, which gives me 4x, and the right side, 21 minus 13 is 8. And then to continue solving, divide both sides by 4. 4 divided by 4 gives me x. 8 divided by 4 is 2. And there we go. That's our answer. Okay, now I said we would go ahead and try both ways. So let's come over here and show you how to take the x to the right hand side. So if I have one x over here and one over here, I'm going to move this x over to this side to take it to the right side of the equation. Because it's a positive x on this side, when it comes over here it becomes negative. If you're not okay with that, you can think about it as just subtracting it from both sides. So I'm going to subtract the x. Then I have a positive 21 here. I'm going to take it over to the left-hand side. Because it's a positive 21 on the right side, I can think of it as becoming a negative when it crosses the equal sign. So it becomes a negative 21, or subtract 21. All right. Or if you don't like that, you can think about subtracting the 21 from both sides. So subtracting it from here cancels it out, and then you subtract it from this side. All right, so now here on the left-hand side, 13 minus 21 gives me negative 8. And on the right-hand side, negative 3 minus x gives me a negative 4x. And in this case, I divide both sides by negative 4. Negative 4, negative 8 divided by negative 4 gives me a positive 2. Negative divided by negative. And then negative 4 divided by negative 4 is a positive 1, which is just x. So we have two ways of solving when I have an x on both sides of the equation. Okay, now that we've kind of gone through a lot of information right there, you might want to go through, maybe even rewatch that part because there's two different ways. For the rest of this though, we're going to be working with this example so that we can get rid of every single fraction because unfortunately most of them will not be the common denominator. And so we won't be able to combine them like we did on this side. And if you need help finding the least common denominator, maybe take a break and go find some information on that, or I'm thinking of doing a quick tutorial on that one as well. But there's also a Khan Academy on finding the least common multiple, so you can search for that, or the least common denominator. Same difference. The only difference is that the common denominator is the least common multiple with just the numbers in the denominator for a rational equation or an equation with fractions. Okay, let's move to the next one. This one, we could go ahead and get rid of the fraction right off the bat, or we can work it out and then get rid of the fraction. I'm going to do both ways. The first way, just ignore the fraction, just know that I have a coefficient in front of the x, and I'm going to try and isolate the x by subtracting the 6. So I'm going to copy this to show my work. Copy. Bring it down here and paste. And if you haven't watched the other tutorials, to get something like this on your screen, this is the equation editor. And to get one of those to come up, you go to Insert over here and press Equation. This drop-down menu gives you the most common, or lots of common mathematical equations. So if you want to create your own, you would do this one with the little pi sign. All right, so I want to subtract the 6 over because I want to isolate the x. So I'm going to subtract the 6. And then I'm going to copy this again, bring it down to show my next step. Oops. There we go. Okay, 20 minus 6 is 14. Now, to get rid of this, I have a fraction times x, which means I need to divide by the fraction. But we don't divide fractions. We always multiply by the reciprocal. So I need to give myself a reciprocal, and I'm going to put it out in front. So I'm going to come up here to Design and give myself my fraction that I'm going to multiply. And the reciprocal is opposite, so I do 3 over 2. And what happens there is I have one on top and one on bottom, so they cancel. I like to think of it like that. Some people like to think of it as 3 divided by 3, which is 1. 1 times whatever is the other number. I like to think of it as canceling it out because then I don't have to do any more calculations in my head. I just think it's gone. And so on that side, I'm only left with x. I have to do the same thing to this side, and I'm just going to copy this fraction over here, bring it to this side, and I should have done that before I crossed them out. There we go. All right, so this side, I'm only left with the x, and on this side, that could look like 14 and 3/2, so I'm going to put a time sign there to remind myself that I'm multiplying. Now that I know that those are canceled, I'm not going to copy them for my next step. Just bring it into here. Tab to keep it all lined up. Oops. Oops. Guess we're going to have to just space over. There we go. Okay, so now let's work on this one. I have 14, and that is a whole number. If you want to think of it as a fraction, put it over a 1, and that's fine. So I have 14 on the top and a 2 on the bottom. So what I like to do is simplify by canceling as much out as possible. 2 cancels into 14, and I'm left with 7. Oops, get rid of that. And what's left up there is 7 because 14 divided by 2 is 7. Nothing canceled out with the 3, so I'm left with 7 times 3, which makes x equal 21. There we go. All right, now that was the first way of doing that one. The second way will be good practice for doing the least common denominator way over here. So I'm going to scoot over. Some of you might be a little nervous by doing this one, so I think seeing it as many times as possible to see this side, I'm going to keep trying to do that. So I'm going to paste that in. Now, to find the least common multiple way, we look at all the denominators. In this case, we're lucky. There's only one, and it's a 3. So you don't have to do any work to find the least common denominator. It's just a 3. And to get rid of the fraction, because some of you might want to get rid of it and get rid of that anxiety right from the beginning, we just multiply everything by the least common denominator, and it totally eliminates all of the fractions. So in this one, I'm going to do 3 times here, and it's to every single term. Remember, the terms are separated by an addition sign, or a subtraction sign, or, of course, the equal sign. So I need to multiply it to every single term. There we go. Now what happens over here with the fraction? 3 divided by 3 is gone. Oops, there we go. There, no more fractions, and that's the only one that cancels. So my next step, I'm just gonna get that guy for my my work. Scoot over, paste it down, and what's left here with the x, the 3's canceled, so I have that 2 left. And 3 times 6, 18. 3 times 20 is 60. There we go. So now again, I have another equation with absolutely no fractions attached. And hopefully your anxiety just went down. There's no more fractions. So we just work it like a regular equation by isolating the x. So I subtract the 18 over. I have 2x over here equals 60 minus 18. My next step, oh, the tab's working again. So I have 2x equals 60 minus 18 is 42. Yep. And then if you're not comfortable with doing that in your head, go ahead and use your calculator or Excel. I'd rather you'd be really comfortable with the calculations and right now worry about working out the equation. Okay, now that I have 2x equals 42, we divide both sides by 2, and I'm left with x equals 42 divided by 2 is 21. So there we have 2 different ways of solving that one. Let's go ahead and move to the next one. We're going to be doing this one through much of today, or of this part 2. Okay, let's go to the next one here. Again, we have 2 different ways of working through this one. We can get rid of the fraction right off the top, or we can kind of work through some things first and then deal with the fractions at the end. It's totally up to you. I think I'll do it both ways again. So I'm going to highlight this, and because I already showed you earlier how to take the x's on the left side and the right side, I'm just going to pick and keep it consistent on both examples on this one. So I'm going to combine the x's and combine the numbers without any variables on the other. So I'm going to pick the left-hand side just to stay consistent and move my 7x over. You can think about adding 7x, or, and then it cancels, and then we would add 7x over here. Another way of thinking about it is just taking this 7x, and it kind of saves you a little bit of time, and once it crosses the equal sign, so you're just dragging it over, it becomes a positive x. So that's another way of thinking about it. Either way, we still end up with 6/5 x plus 7x plus 8 equals 20. Now I need to get rid of this 8 and 20, so I'm going to bring this guy over, and I'm not going to worry about trying to add those fractions because, yeah, you could worry about being mixed fractions. I'm not going to do that though. So I'm going to take that 8 over, so it becomes a -8. There we go, or subtract 8. And don't worry about this side yet. Let's just combine these guys. So 20 minus 8 gives me 12. Oops. Get those guys over. This becomes 12. There we go. Now you could go ahead and worry about adding those together and get 7 and 6/5 and then mix or change that into an improper fraction. I'm not going to. I don't want to worry about any of the fraction mess. I just want to get rid of it now. So what I've done is I have combined it so I have one fewer term to worry about. And lucky for us, there's only one denominator, the 5, so the common denominator is just 5. And I need to multiply it to what? Do you remember? Every single term. Those are separated by addition and subtraction signs. So I'm going to do 5 times this term, 5 times this term, and 5 times that term. And what happens is that fraction is totally gone. And because it's gone, what am I left with over here? Actually, I'm just going to copy to here because I don't have a fraction anymore. I have a 6 there now. And over here, 5 times 12, 60, and 5 times 7 is 35. There we go. So now for my next step to show my work, 6 plus 35 gives me 41. X equals 60. Divide both sides by 41. In this case, the 41 doesn't cancel out with anything, so I'm just left with x equals 60 over 41. All right, so that was the first way of doing it. The other way is to just get rid of the fractions right off the top. So I'm going to come over here. There we go. So I only have one denominator, which is the 5. So the only common denominator that I have to worry about is just 5. Multiply it to every single term. It's so important to remember every single term. Now remember, we did talk about how if you have a large fraction bar like this, that's kind of like saying I have parentheses here, and this is just one term. We'll come to some other ones later that also only have parentheses, and that's also one term. Even though there's an addition or a subtraction sign in there, they're combined by that long division sign or the parentheses, and they're considered one term. But in this case, nobody's combined. I have 1, 2, 3, 4 terms. So I multiply it to everyone. This guy is gone. I'm only left with a 6 there now. And then I just multiply everyone by 5, keeping it consistent. And I'm not even going to copy my equation over because this will be fast. What's left here? I have 6x plus 5 times 8 is 40 equals 5 times 20 is 100 minus 5 times 7 is 35x. And then we just do what we did from the beginning or what we did before. Combine all the x's on one side, everything without the x on the other. So I'm going to do the opposite here, which is add 35x. So I'm going to come down to my next one. 6x plus 35x plus 40 equals 100 is the only thing left. And then 6 plus 35 is 41. So this gives me 41x. And I still have that 40 over here. Not for long, because now I need to separate that and move the 40 over. So I have 41x. I need to subtract that 40 now. So I have 100 minus 40. 100 minus 40 is 60. So 41x equals 60. Now I need to continue isolating the x by dividing both sides by 41. Dividing that side by 41 leaves me with just x. Divide this side by 41 and nothing cancels, so I just have 60 over 41. There we go. Now if the instructions were to say change it to a mixed fraction, you would go ahead and do 41 goes into 60 one time and put the leftover over 41. In this case, most of your problems, you'll just go ahead and keep the 60 over 41. Okay, let's move to the next one. Parentheses, we already talked about that. This is considered one term because it's kind of grouped together with those parentheses, just like that long division sign. And just to get some more practice, let's go ahead, and I'm not going to do this way anymore. I'm going to just go ahead and do this way, which is getting rid of the fractions right from the very beginning. But there's lots of ways that you could go ahead and do this. So right from the beginning, I want to get rid of that fraction. I'm going to copy and paste it down here for my next step. Okay, so lucky for us, there's only one denominator. So that's kind of nice, and we just want to get rid of it. So we're going to times everything by that least common denominator, which is 2. So 2 times. And notice, because this is in parentheses, I only multiply that 2 out in front. Don't try and multiply it in. It's only one term. On this side, though, these are not in parentheses, so these are 2 separate terms. I'm just going to multiply that by 2 times. Okay, so over here, the 2 on the top cancels out with the 2 on the bottom. The other way of thinking about it is that they're dividing out. And so I'm only left with a negative 5. I'm going to go ahead and bring that down since I had already copied it over. So I'm going to get rid of this fraction in here, delete, delete, and give myself the 5. And over here, 2 times 6 from this step gives me 12. 2 times 2 here gives me 4. Now, no more fractions. So hopefully the anxiety's kind of gone down a little bit, and we're going to move to the next step. I'm just going to copy this, paste it down here. Some of you may be just fine with going to this next step without me saying it. How do I get rid of those parentheses? By the distributive property. I need to multiply the negative 5 into the x and into the 12. So I'm going to delete these parentheses. Oh, it's combined, so we'll just type it in. X plus 12. So I'm going to multiply the negative 5 into the x, which gives me negative 5x. Negative 5 into the 12. Negative 5 times 12 is negative 60. Oops, not plus and minus. We want minus 60. There we go. Okay, so now I just need to decide which side I want to take all of my x's to and everything without the x to the other side. Just to stay consistent, let's put the x's on the left. It's just common. So I'm going to move my minus 4x over. So when I bring it over here, it becomes positive 4x. So I have negative 5x plus 4x minus 60 equals 12. There we go. Negative 5x plus 4x gives me negative x. And then minus 60 equals 12. The next step, I need to take that 60 over now, so it becomes a positive 60. So I have negative x equals 12 plus 60. 12 plus 60, negative x equals positive 72. But I'm not done. I need to get rid of that negative sign on the x. So I need to divide both sides by a negative 1. Negative 1 divided by negative 1 gives me a positive x. and positive 72 divided by that negative 1 gives me negative 72. All right, for some reason, this started giving me wrong numbers. So, yep, number 4 is 72. Oh, it should be negative 72. There we go. And I'm going to change that. All right, let's move on to the next problem. Oh, I see when I was first writing this problem, I had a negative on this side that I took out. All right, let's move to the next one. Now that we're getting really familiar with getting rid of the fractions, that's all we're going to do is just get rid of the fractions. And lucky for us, the only denominator here happens to be 7, so we don't even need to calculate anything for the least common multiple. So I'm going to copy all this, and the very first step, get rid of that and bring your blood pressure back down. No more anxiety. All right, so the least common denominator here, very easy, it's just a 7, multiply it to every single term. 7 times here. This is one term because it's combined with the parentheses. So I only need to do the 7 times out in front with this 2 7s. And then here, 7 times. These guys are not in parentheses, so both of them get the 7. Don't forget, both sides, every single term. That's probably the biggest problem, is that a lot of people forget to do it to every single term. All right, they just kind of get rid of it. And what's important is that on the right-hand side, a lot of people forget to multiply that 6 by the 7, and they just get rid of all the fractions, and you have to keep it balanced. So over here, I'm going to delete this because those 7's canceled. I'm only left with a 4. And here, the 7's canceled on the previous step, which leaves me with 2. Here, the 7's canceled, which leaves me with 5. And here, it doesn't cancel out with anything, and that's probably the tricky part, is a lot of people forget that. So I need to multiply those, which gives me 42, not just 6. All right, so now the next step, I need to get rid of these parentheses by multiplying in with the distributive property, and I like doing my little rainbow kind of an idea. I'm going to copy this guy and bring him down to show my work. All right, so I'm going to multiply that 2 into here. So 2 times x gives me 2x. 2 times 8, and those are both positive, gives me plus 16. All right, let's combine all like terms. I'm going to copy this one, bring it down. 4 plus 16 is 20. There we go. Now we just need to decide which side we want all of the x's and everything without the x. I'm going to go ahead and bring my 5x over just to stay consistent and put all the x's on the left. But if you'd like to put it on the right, it's up to you. A lot of people start figuring out that, like on this one, if we had brought the 5x over, it would have kept the x positive, and it would have saved us this last step. If you want to get to that point, that's fine. If you don't, just keep putting them on the left and it works the same way. Okay, so I'm going to bring my 5x over, which makes it a positive 5x here. Add 5x. And if we would like to go ahead and combine 2 steps at once now, if you don't want to, ignore this and move on to the next step by copying and pasting this one down, or rewriting it if you're doing it by hand. However, I'm okay with now moving the 20 over because I know in the next step I'm going to subtract the 20. All right, so now I'm going to copy this, bring it down, and 5x plus 2x gives me 7x. Negative 42 minus 20 makes negative 62. There we go. And now I just need to solve for the x by isolating, actually I don't even need to copy that. We'll just do x equals divide both sides by 7, which gives me negative 62 over 7. And highlight that because it's our answer. There we go. Let's go ahead and move to the next one. And I have to say, I think this is the one that these fraction equations are the ones that get everyone. It's that anxiety and seeing lots of fractions. Okay, now we've moved to our very first example where there's multiple numbers on the bottom for the denominator. These ones aren't too bad. It's pretty nice. A lot of people, for their common denominator, just multiply the bottoms together. And so in this case, they would get 8. Now that is a common denominator, and at the end you will have to simplify because I didn't find the least common denominator. So I want to find the smallest number so I don't have to do more reducing at the end. In this case, 2 goes evenly into 4, so the least common denominator here is 4. And remember, what do you do with that? Multiply it to every single term. This parenthesis guy, he's already stuck together, so you don't have to worry about him. It's just one term. These guys aren't stuck. So multiply, 4 times. And don't forget this guy, even though he doesn't have a fraction, he is still a term. There we go. Okay, so now here, you'll notice the 4's cancel out on all of the ones that have the 4. Oh, you can't see it cancel out on the 4. Um, we'll just copy that and bring it down to the next line to show our work because it crosses it out right over top of the 4. Okay, so these ones, the 4's cancel, and I'm left with 3 here. The 4's cancel here, which leaves me with just 5. Here the 4 does not cancel, so I multiply and give me 12. Okay, now let's come over here. It did not cancel exactly perfectly on this one because 4 divided by 2, it does get rid of the 2. That's true, but it doesn't get completely rid of the 4 because 4 divided by 2 leaves me with 2. And I'm going to go ahead and leave it just like that to show that I canceled that 2 out. I can come down to the next line. And there we go. Keep things all lined up. Okay, so now 1 is left here. 1 times 2 is 2. There we go. No more fractions. So now we just work it out like we did the other ones. Your heart rate stopped beating and it's a lot nicer. So here we go. Or stopped racing, not beating. Okay, so we multiply this in through the parentheses using the distributive property. So I'm left with, and I don't need to copy this anymore because I don't have any more fractions, 2x plus 3 times x gives me 3x. 3 times 5, positive 3 times positive 5 gives me positive 15 equals 5x minus 12. There we go. So now we just need to combine everything. The next line, 2 plus 3 gives me 5x plus 15 equals 5x minus 12. Now, I didn't intend for this to happen this way, but I thought it was a nice review. Some of you can stop right here and know something's wrong. If I take 5 times a number and add 15, and 5 times a number and subtract 12, they won't be equal to each other. So this is wrong. Some of you would like to continue going by subtracting the 5x, and that's fine. So when you subtract 5x, the x's are gone, and we're left with something crazy like 15 equals negative 12, which will never happen, and so the answer is no solution. So that was kind of a fun little review. Please note, I don't believe any of yours on your homework will come up with a no solution on these fractions with equations with fractions. It was just kind of fun to see it. Okay, let's move to the next one. Okay, so we look at the denominator. Get rid of them. I have a 3 and a 5. 3 and 5, the smallest number they will both go into is 15, which happens to be the product. So like we talked about previously, some people just like to multiply everything by what the two numbers multiply together to be. In this case, it happens to be that. So I'm going to copy this actually and bring it down for my next step so that I have my original problem still there. Oops. I was trying to do it fast. Okay, so my least common denominator is 15. There we go. And times it to every single term. 15. Oops. 15 times. 15 times. There we go. So over here, unlike the previous examples, it doesn't just cancel out. I'm left with something else. 15 divided by 3, it does cancel out the bottom, which is our goal, but it doesn't cancel out everything on the top. So 15 divided by 3, it does cancel that part out, but this becomes, I'm going to bring that down for our next step. This is gone on the bottom. 15 divided by 3, it cancels some of it out, and I'm left with a 5. 15 times 10 is 150. Here, again, the bottom's going to cancel, which is our goal. We want to get rid of all the fractions. But here, it doesn't cancel all of it out. Dividing that by 5 leaves me with 3. And then 15 times 7, if you're not sure, be comfortable. Just use your calculator. I'd rather you worry about working through the equation, which gives me 105. There we go. Okay, so on this left-hand side, because the 3 did cancel out the 15, I am still left with the 5. So I need to multiply 5 times 7, which gives me 35x. And then I have my 150 here, and equals 3 times 1. It's just a 3, so that's nice. X minus 105. There we go. So it looks exactly like the other problems. And we just combine the x's. I'm going to go ahead and move my 3x over. So I have 35x. And if you want to go ahead and write minus 3x, that's fine. Some of you are probably getting more comfortable with going ahead and writing out when you subtract that over. Some of you might skip that step and just put in 32. For our sake, I'm going to continue writing those out though. And the 105 is still negative. Okay, so now we know 35 minus 3. Oh, well, we'll just delete, put a 2 there. Okay, now I need to combine everything without the x's on the other side. So subtract the 150 over. Oops. Minus 150. And over here, this was 32. Okay, so my next step is 32x equals negative 105 minus 150. If you're not comfortable, I'd rather you worry about what's going on with the equations. Now, I did do negative, or I did positives. I should have done negative, but I had to type that out. And that's minus 150. So all it does is change the negative sign. So this is negative 255. There we go. And continue solving for x. I divide both sides by 32, which leaves this side to be x. And then I have negative 255 over positive 32, which is negative 255ths, 30 seconds. There we go. Highlight my answer. Okay, let's try the next one. Okay, I have 1, 2, 3, 4. I don't think you will see this in your homework. This one's kind of crazy and intense where I have lots of different numbers. So this will be kind of one of the little tests about what will be the lowest common multiple that all of these denominators will go into. What is the smallest number 3, 4, 2, and 6 will all go into? Let you pause and think for a minute. Some of you are okay right off the top. I'm going to copy this down. The smallest number that all 3, 4, 2, and 6 will go into is 12. Oops. So I'm going to multiply every single one of those by 12, and it will get rid of all the fractions on the bottom. It'll leave me a little bit on the top that I have to work with, but then I don't have any fractions, so that's nice. So 12 times. Now these guys are in parentheses, so that's one term. Leave it alone. It's done. This is another term. Here's another term. It's not in parentheses. So I need 12 times. And don't forget this last guy. I need to times that by 12. There we go. So over here, the 12 does not cancel out completely, but the 3 does. You know, let's make that another step so that we show as much work as possible. So here, the 3, it's gone. And 12 divided by 3 is 4. So I'm left with the 4 there. I don't have to do anything else now. I will later when I do the distributive property. Here, 12 divided by 4 is 3. So that's gone down there. 12 divided by 2 is 6. So that's gone. And 12 divided by 6, that's gone, gives me 2. Good, no more fractions. That was our goal. You know, I'm not going to copy that down. I'm just going to go ahead and multiply now. 4 times 5 gives me 20. And then I have 2x still in here plus 7, close the parenthesis. And then I have 3 times 5 left there, which is 15, equals 6 times 1 is 6. So I have 6x. And then 2 times 1, so minus 2. Does it look nicer? Hopefully the anxiety went down, there's no more fractions, and we can just worry about how we did the other ones. Oh, I put times, that should be plus. Okay, so distributive property gives me 20 times 2 is 40x. 20 times 7 is 140 plus 15 equals 6x minus 2. Okay, so now we just need to combine what we have. So on this side, I can't combine anything with the x's yet, but I can combine those guys. So 40x, 140 and 15 becomes 155 equals 6x minus 2. Okay, so let's just move the 6x over on the next step. Oh, and I'm running out of room. Okay, so I have 40x minus 6x. And I'm going to go ahead because I'm running out of room and I'm going to move my 155 over. So that's subtracting 155. So it becomes negative 155. And I still have a negative 2 over here. Looks like I'm just going to need to get some more room. Okay, 40 minus 6 gives me 34x. And then I have negative 155 minus 2, which gives me negative 157. Then divide both sides by 34. Leaves me with just an x on the left. And nothing simplifies over here. It's just negative 157 divided by 34. There we go. And I think, do I have enough room for the last ones? Oh, we'll go on to the next page. Okay, so there we go. That's the end of number 8. Let's move to the next example. This one is very similar to the one we talked about earlier, where a lot of you are thinking, wait a minute, I can just go ahead and do what I learned, which is called cross multiplying. And the reason cross multiplying works is that when you multiply by the least common denominator, in this case, it's 24. When I multiply it to both sides, I cancel out the 6 and I'm left with the 4 on the left. And when I multiply it over here, the 24, it cancels out the 4 and I'm left with the 6, which is why a lot of people just simplify it by saying 6 times this and 4 times this. Just to stay consistent though, I'm going to put the 24 times on both sides just so that you can see that's why it works. If you want to do cross multiplying in your head, you can think of that. So down here, the 6 cancels, and I'm left with 4, and I'm left with x plus 5 equals, the 4 cancels, and I'm left with 6, and this is 8x plus 3. And you'll notice I put on parentheses over here because we talked about how when it's over a long division sign, it's all combined as one term. And then we just use the distributive property. Okay, so distributing that in, we get 4x. 4 times 5 is 20 equals 6 times 8 is 48x plus 6 times 3 is 18. Okay, now we just need to combine everything on one side. Let's go ahead and move my 4x to the right side. I'm doing that because I can see if I subtract 4x to this side, it'll keep my x's positive. And subtracting my 18 also will keep this positive. So my next step, I'm going to subtract that 4x over, which gives me 48x minus 4x, and I haven't done anything with the 18 yet. So 20 equals 48x minus 4x gives me 44x, and I still have this 18 over here, which I need to bring to the other side now. So my next step, 20 minus 18 equals the 44x, and the 18's gone on this side now. 20 minus 18 gives me 2 equals 44x. And to continue isolating the x, divide both sides by 44, which gives me 2 over 44 equals x, which simplifies, dividing both the top and bottom by 2, 1 over 22 equals x. There we go. So it wasn't too bad. Let's move to the next one, number 10. And to give us a little bit more room for number 11, I'm going to bring those up just a little bit. Okay, here we have, again, two denominators that are different. We need to find the least common denominator. 15 happens to go into 30, so the least common denominator here is 30. I'm going to copy this and paste and multiply both of these by 30. Okay, so multiply every single term by 30. 30 times, 30 times. And the reason I do it out in front is because it doesn't, it gets kind of muddied if I put it at the end. So here, the 15 will cancel out. And let's just go ahead and bring that down. No, I think we'll do it all at once. So the 30 cancels with the 15, or the 15 cancels, and I'm left with 2. And I'm going to put parentheses here because that whole x minus 8 is combined on top of that division sign, or the fraction, so it's still together as one term, equals 30 times 3 is 90. Over here, the 30s will cancel out, so that's minus. They're totally gone, so I'm only left with the 3x. There we go. So the next step I have here is doing the distributive, which gives me 2x minus 16 equals 90 minus 3x. And just pick a side to combine. I'm going to bring my negative 3x over so that it's a positive x. It'll just save me a little bit of time. So I'm going to add the 3x here. I'm not going to worry about the numbers without a variable yet. So I'm adding this 3x over here. 2x plus 3x gives me 5x minus 16 equals 90. Now I need to take that 16 over, so it becomes positive, and I get 90 plus 16. So I have 5x equals 106. Okay? And then to continue solving, I get x equals 106 divide both sides by 5, it cancels on the right hand side, and I get 106 over 5. And highlight my answer. I guess we didn't give ourselves too much room for number 11. Okay, the first and only example I have with decimals. The trick here, you could go through and change all of these to, in this case, this is 9 over 100 or 900ths. I don't do that. The trick is to find the largest or the decimal that comes out the furthest. You don't include the zeros after, so if it tries to trick you, don't worry about those. Go to the number and see which one has the most decimal places over. So this one has 2, this one has 3 decimal places over, this one has 4, and that's the highest one. So we find the largest one, and that is, to get rid of that decimal, I multiply by 1, 2, 3, 4 zeros. So that's by, my least common denominator is 1, 2, 3, 4 zeros. 10,000. Another way of thinking about it is times, of course I'm going to times this to every single term. Another way of thinking about it is just moving the decimal places over 4 places for every single term. Now the only problem I find that if somebody does just moving the decimal places, that they might accidentally make a mistake. So I'm going to write it out for every single one of these for a moment, quick. 1, 2, 3, 4 times. Okay. Sometimes if you take that shortcut and you find you move it over 4 decimal places, which is the faster way, and some of you will be okay with that, that once you get going, some people accidentally only move it over 2, and then this one they move it over 3, this one they move it over 4, and they think they just moved the decimal to the end of the number you see. And that's not true, because the least common denominator here is 10,000, which means I need to move the decimal 4 places every single term. Another problem with that is a lot of people move it over 4 places, but they forget this guy on the end, that 3, and that also has to be moved over 4 places. So this is kind of a foolproof way to make sure that you times it by, remember you count the zeros, this was 1, 2, 3, 4, and you just times it by 1 with the 4 zeros at the end. If this happened to be like this, then we would count and see this one has 2 decimal places, this one has 3 decimal places, that one has 3 decimal places, and I'd only be multiplying everything by 1,000. However, that wasn't the example, so I'm going to put that 0 back in here. Okay, so you have those 2 different ways, it's up to you, and so this one I'm going to move it over 4 decimal places. 1, 2, 3, 4. So that gives me 900x. So you see the problem that some people would run into in doing the shortcut, which is just moving the decimal over the same number of times as the largest decimal that you have. Or I guess it would be actually the smallest decimal, but the most decimal places. Is that some people get stuck and only make that a 9, when really it should be 900. So you have 2 ways. Some of you will be okay with just moving it over the 4 decimal places. And go ahead and use that trick. I think it's much faster. But I'm going to go ahead and write out the least common denominator, which in this case is 10,000. Okay, so in this one I need to move it over 4 decimal places. So 4, 6, 1, 2, that's only 3 decimal places. So I need to tack on that 0 to move it over 1 more. This one, moving it over 4 decimal places, gives me 8. And the other problem is that a lot of people forget to move it over on the whole numbers because they don't see the decimal, it doesn't remind them. But when you multiply that by 10,000, you get 30,000. There we go. So you have your 2 ways. You can find the largest number of decimal places and move every single term the same number of decimal places to make them all whole numbers. And some of you will be just fine doing that. And I think that's great. The foolproof way, though, is to make sure that you write every single term being multiplied by, remember we counted the decimal places, 4 zeros, so it was 10,000. Okay, Here's your next step. Combining the x's, I'm going to move the 8x over. So I have 900x subtracting 8x. And I still have this 46,120 equals 30,000. And my next step, 900 minus 8 gives me 892x. And that's going to still be adding to 46,120, which equals 30,000. And then I need to move my 46,000 over. Oops. There we go. So I have 892x equals positive 30,000 minus 46,120. Let's come over, and I don't want to worry about that. I just want to have the answer. So 30,000 minus 46,120 is negative 16,120. Oh, I hope I have enough room. Oh, that's okay. So I have 800. There we go. At least it's a little more together. 892x equals negative 16,120. And then divide that to isolate the x. So I have x equals, because I've divided both sides by 892, negative 16,120 divided by 892. Now, if I had started out with fractions, this answer would be completely appropriate. However, I started out with decimals, which means my answer should be in a decimal. I've noticed on your homework that that doesn't stay consistent. I would say if you can get to the fraction, then you're good. If the answer on the test or on your homework is in a decimal, go ahead and just plug it into your calculator and give it as a decimal. There's no set rule on your homework as of yet in which it tells you what you should round or if you should give your answer in a fraction or a decimal or a mixed number. So don't worry if it doesn't match exactly. If you know how to change it from what you've gotten to the decimal, or if you have the decimal and you change it to the fraction or the mixed number, then you're fine, because on the test they're all multiple choice. And so you can just find whichever one matches. Okay, enter, and 18.07, and I seem to have forgotten my negative sign in here. There we go. So my answer is x equals negative 18 point, and because I'm the teacher and I just said let's round out 2 decimal places, let's go ahead and do that. In Math 108, it will be stating on each of them how many decimal places to be rounding your answers to, or if it wants it in fraction form. All right, so that's all of our examples for part 2. If you have any questions, write me, email me, make a comment, and I'll help get back to you. And good luck on your homework.